Could you survive? The unit I have created is a grade 7 science chemistry unit called Using Chemistry to Survive on a Desert Island. This is an introductory module to get students excited about chemistry as well as using their critical thinking and problem solving skills. It's linked to the Australian Year 7 science curriculum. In Tasmania, we don't have a separate curriculum guide for science. We fall directly under a CARA system, and its mixtures including solutions that contain a combination of pure substances that can be separated using a range of techniques. Students start out with showing us what they know. I found this to be a great use, especially in science, to address any misconceptions, as well as just trying to get an understanding of starting points. So students participate and contribute to a Padlet. Through the Padlet, the students are also able to see what other students are writing at the same time, and this can hopefully be used to jog their memories. Based on the Padlet, and just to expand their knowledge, one of the most important parts of the science chemistry unit is the new vocabulary, understanding what the different words mean, understanding what homogeneous solutions are. And one of the videos and Web 2.0 tools that I found to be really successful and useful with my cohort of boys is vocabulary videos. Short, sharp, quick videos that are usually 4 to 5 minutes maximum that normally contain some sort of either irritating tune that gets stuck in the kids' heads or some catchy rap that the boys can't stop saying, and this really helps them later on. They're always encouraged to make notes in their science lab books, and also by using this video they can watch it over and over and over as many times as they want to until they're absolutely confident. Next is putting their knowledge to the test. I've decided and gone with the use of technology for definition and word match. This has specifically been chosen for the fact that there's no finality in it. The use of technology provides support to the students being able to move their definitions and word matches around. They don't have to worry about making mistakes, ripping pages up and starting again. In this way, really giving them the chance to play around and make those decisions and not have to worry about whether they're going to be asked to redo it if they've made a slight mistake. In Lesson 2, they're presented with a real problem. They watch a short clip that opens up on a desert island. They realize they're stranded, they've got absolutely nothing there, and they're in desperate need of water. As soon as they find water, they realize it's not drinkable. And this gives them the problem and the connection to a hands-on real problem that they're going to have to solve. And they asked how they can separate a mixture of sand, salt, and seawater to enable to them to get drinking water. Luckily for them, a whole bunch of their science equipment landed on the island with them. They're given one goal only, and they're asked to follow the 3 simple steps to try and work out how they can do that. Finally, they're asked to show their explanation and how they got to that step using Movely. Specifically, I haven't asked them to get the process correct before going to making this explanation video. I'm hoping that the students capture some of their trial and errors, their testing, their iteration, their ongoing movement. Students have used Movely before, but for those who aren't 100% certain what to do, I've included a link to help them with this, and they've got a student account. Fantastic way for them to show that. Finally, now that they've done that, they've prepared it, they know what they're doing, they're asked to design and produce in Lesson 3. So they're actually going to get to design and produce their own water filtration water bottle that can hopefully save others in futures. They're going to grab their partner, online brainstorming. Both people can collaborate at the same time in a OneNote class notebook, and given them some websites which they can use. Next, they have to obviously pass this through myself in order to get the secret code to Tinkercad. We've used Tinkercad extensively before as a Web 2.0 collaboration tools for designing, prototyping, and producing. There's the added feature of the collaboration, meaning both students are able to work on the project together. One student doesn't necessarily do more than the other student, and they're both able to make changes. Again, students have been exposed to this previously, but just in case, and I do have one student who's new to the class, there's an explanation video and a link with how to tinker just to get started with some of the basics. Their water bottles will be printed overnight, and hopefully they'll be able to send them the next day and give them to the class next door to test them. Teacher notes guides the teacher through the links to the Australian curriculum, the learning intentions for each of the lessons, as well as explaining that more than anything, we're trying to make this area of science interesting and engaging. Chemistry and separation and mixtures can be a bit dry and bland sometimes, and especially being at the end of the year, it's probably one of the more challenging units to spice up. We're building on their prior knowledge, following a social constructivist process and pedagogical underpinnings, working with their peers. I feel very confident following this approach at this time of the year, knowing that by now I have worked through a gradual release model of explaining and teaching and guiding my boys, as I wouldn't necessarily feel this confident at the beginning of the year, just letting them loose with open-ended tasks and constructivist building without substantial teacher input and scaffolding. So that's my units. Technology has been specifically chosen to enhance the students' learning outcomes and development and their cognitive and higher order thinking processes. Thank you very much.